Hello guys, I hope you're fine. We are entering a brand new object-oriented programming language called C++. Let's take a brief look at the concepts of class and objects. Class is a general definition and the objects are the specialized definitions of it. For example, car is a class. However, green Ford Mustang with gasoline is an object. This is another object, and this is another object created from that general class. What are we going to do today? We will just create a class calculator, and then we will create two objects named Casio and Canon from that class calculator. These two different brands of calculators will be absolutely identical. However, each will have its own memory. In order to implement this, we should have our main file in the source files folder. Our main file is named as lab8.cpp, and two files in order to implement the calculator class as calculator.cpp and calculator.h. Don't forget, we are putting calculator.h in the header files folder and calculator.cpp in the source files folder. While defining a class, we should first create the calculator.h. After creating calculator.h, we should create calculator.cpp and last but not the least, lab8.cpp. Let's have a look at the calculator.h. This file is the general definition of the class calculator. It roughly determines the general structure of the class, its public and private members. These members could be functions or variables. Don't forget. These lines are called include guards. It simply prevents the conflict of the duplicate libraries. Firstly, we define the class calculator between these curly braces. Don't forget that semicolon, by the way. These member functions and this member variable are all public. What is public? The user can reach them in the main function. As you can see, we can directly reach the memsquare function. We can directly reach the memory variable. However, we cannot directly reach the result. We cannot reach the canon.result. It's private. However, memory is public. If we make this result public, that means we can directly reach the result from the main function. However, we don't want this. We want this variable as private because we don't want the user change this variable from the main function. So I'm doing this private. Sorry. When we look at the header file again, we see that function. It's called constructor, and it should has the same name with the class itself. This is a member function sum. It accepts two parameters as floats and returns a float. These remaining member functions are also have the same behavior. This member function memsquare accepts no parameters, however returns a float. This member variable memory is float and initialized to 0. This result is a member variable and it is private and initialized to 0. And let's have a look at our calculators that we have drawn. What we see as a user on the calculator, they are all public. What are they? Sum is here, mul is here, sub is here, div is here, and the memsquare is here, memory is here. However, we don't see the result variable on the calculator. It is hidden inside. We cannot directly access it. However, it's used indirectly. Okay, that was our header file. And let's look at the calculator.cpp. Now, in this file, we are defining the behaviors of the functions, how they work, and what are they doing. We should include calculator.h in order to connect these two files. These two columns are called scope resolution operator. It simply indicates this calculator function is in the scope of calculator class, and it's used for different purposes. Now, this syntax means constructor function, which was a member function, calculator of class calculator, takes no parameters and does nothing. And when we look at this syntax, the member function sum of class calculator takes two parameters as num0 and num1 as floats and returns float and does this operation. It simply adds two numbers and sends them to the private variable and returns the private variable. So, despite the user cannot reach this private variable, it can be used in the class itself, as you can see. And these remaining functions have the same behavior as the sum function. And let's look at the memsquare function. The member function, sorry, I have a mistake in here. This should be memsquare. It takes no parameters and returns float. How? It simply takes the square of the public variable memory and assigns the result to that variable result and returns it. Don't forget, this memory variable was public, so the user easily can manipulate it. When we look at our calculator, this memory corresponds to that mem variable in here. Don't forget these semicolons after the curly braces, and don't forget to include the constructor function. It is essential to create the classes. And don't forget these names, these types, this class name, this constructor function, these variables, these variable types should match with the definitions in the calculator.cpp. They are all case sensitive, and if you do one of them wrong, such as if you write the name of this function sum wrong, they will mismatch and give an error. It goes for the constructor function. It goes for the types. Declaration is incompatible with Float calculator, it says. So it is float. So we have finished these two files, I think. Let's look at the main function, lab8.cpp. We are including IOStream for using cout, and we are including the calculator.h in order to use the library that we wrote. It's amazing, right? We have just wrote a library named calculator. Yes, the first library that we have written. Now, cout is an pre-created object which is in the scope of the std namespace. So cout is a special object. It's used for printing something on the screen. Now we are creating the Casio object from the class calculator, and we are creating the Canon object from the class calculator. Yes, what we have done. We have just created these two calculators. Now we are defining a floating variable, my result. Now when we write Casio.memory, it means the memory of the Casio object. What are the functions of Casio? In order to learn it, we just simply write Casio dot. It has division, memory, memsquare function, mul, sub, and sum. We don't see the private variables in here. However, if you are eager to see these private variables or functions, you simply press that plus button and see the private variable as locked. Now the memory of the Casio is equal to 3 and memory of Canon is equal to 4. Now my result is equal to Casio's memsquare function. Remember, memsquare simply takes the square of the memory and take the square of the Canon's memory and make this division in the Canon calculator and make this summation in the Casio calculator. This is normally the left shift operator, however, it is specialized for using with this cout object, as known as it is overloaded. Since it is overloaded, it is indicated as different color. If it is not used with cout object, such as with a standard number, as you can see, it is not green colored. In here, it is shifting 2 by 3. However, in here, it's just printing my result on the screen. Okay, let's run the program by pressing F11 button. F11. Casio's memory is equal to 3. Canon's memory is equal to 4. Okay, my result is Casio's memsquare. Yes. Casio's memsquare is called. Result is memory times memory. Memory was 3, and the result is equal to 9. And return result. Return result. And my result is equal to 9. And print my result on the screen. And call memsquare. Memory was 4 and result is 16 and return result. My result is equal to 16 and print this on the screen. Yeah, that's all, folks. Thanks for listening and see you in the next lecture.